Hi guys, welcome back to Nunley Math. I'm Aaron Nunley. Thank you so much for joining me here today as we begin a new series of videos where we examine the area of two-dimensional figures. Notice that this lesson is called Area of Rectangles, Parallelograms, and Triangles. I'm actually going to split this video up into 3 shorter videos, so make sure you check out all 3 of those to get the entire lesson. In my class, we would probably cover all 3 of these shapes in one day since I teach 7th and 8th graders. Most of them have seen these things before, and so all we're doing is refreshing some ideas in their mind. But depending on what grade level you're at and your familiarity with these, you might want to split this up over several days. But we're going to go ahead and dive in on the area of rectangles. I want to remind you, first of all, that area is often defined as the amount of space inside of a two-dimensional figure, or the amount of space that a 2D figure occupies. So you can see I have a rectangle drawn here. This rectangle measures 7 inches across and 3 up and down. Or you could say this rectangle has a length of 7 inches and a width of 3 inches. But I want us to think of an alternative definition for area that says something more like this: the number of squares that fit inside of a two-dimensional figure. And I define area this way on purpose because I find that a lot of students struggle with the area formulas and why that gives us the area. And so to me, it makes more sense when we think of area in terms of the number of squares that this shape occupies or that can fill the shape. So what I'm going to do is I'm going to start off with this. This is a square inch. I know it's a square inch because it is a square and it measures 1 inch in both directions. 1 inch long, 1 inch wide, so we call it a square inch. And when we're talking about area, we're always asking ourselves how many squares would fit inside of this shape. And so what I'm going to do is I'm going to keep adding squares along the top edge of the shape until I reach the end. Notice that since this shape is 7 inches long, I can fit 1, 2, 3, 4, 5, 6, 7 squares across the top of this rectangle. I can fit a row of 7 squares. But notice that this row of 7 squares does not completely fill the rectangle. In fact, if I were to put a row of squares up and down, you can see that this rectangle is 3 squares long, which should make sense because if each square measures 1 inch, 1 inch, and 1 inch, we should be able to see that there are 3 that would fit along this side. Now, knowing that, I can imagine that these 3 squares, 1, 2, and 3, can be used to help me predict how many squares would fit inside. This is known as an array. When I arrange shapes or objects into a pattern where I can count along the top and I can count up and down, I can use those to compute the number of squares or objects in the array. So if I know that there are going to be 3 rows of 7 squares, here's your second row of 7 squares. Here's your third row of 7 squares. Without actually seeing every square, I can look at this and say, oh, there will be 7 squares across, 3 squares up and down, for a total of 21 squares. We use this idea of an array to help us create the area of a rectangle formula. Area equals length times width. Since I look up here and I can see it's 7 across and 3 up and down, I know it's going to be 3 rows of 7 for a total of 21. Notice usually we write that as area equals length times width, or A equals L times W. And if I know the length and the width, I can compute the total area without having to draw each square individually. So let's look at this. If someone were to give me a rectangle that measures 6 inches long by 5 inches wide, or 6 inches long by 5 inches tall, depending on which way it's turned, I would always tell my students to approach these problems the same way. You begin with your formula, or the pattern we know always works. We substitute in the specific values for the specific shape we're talking about. In this case, the specific measurements for this rectangle. And then we simplify to see how many squares it would take to fill this particular shape. So, since I know it's a rectangle, the area of any rectangle we said is the length times the width. In this specific rectangle, we know that the area equals 5 times 6. That's 5 rows of 6 or 6 rows of 5, depending on which way you would like to look at that. And when I multiply those together, you will notice that that is a total of 30 squares, or 30 square inches. In other words, if I wanted to fill this with 1 inch by 1 inch squares, I would need 30 of them because I need 5 rows of 6 or 6 rows of 5, depending on which way you wanted to read that. Now, I think I'm going to do it for you in groups of 6. Notice it takes 6 squares to get all the way across. That's here. And I know I'm going to need 5 rows of that. So there's a second row of 6, a third row of 6, a fourth row of 6, and a fifth row of 6. Notice that it takes 30 squares to fill the entire shape. Not too bad, right? Here's one for you. This is a little messier. 2.5 inches by 3.5 inches. Can you compute the area for this? If you feel pretty confident, just pause the video, try it on your own. Remember, we're always going to use the formula, substitute, simplify method for doing this. And our formula for a rectangle is area equals length times width. I plug in my length, I plug in my width, and then I compute that, and it comes out as 8.75. Now, I'm not going to perform this computation for you. I'm going to assume you already know how to multiply decimals. Otherwise, this is not going to make sense to you anyway. Area equals 8.75, and this would be inches squared. Some people struggle to try and understand why it's 8.75 inches squared, but if I were to show this to you the same way we did on the other shapes, I would say that it takes 3.5 rectangles to go all the way across. Notice I have 1, 2, 3, and then I have half inside and I have half outside. This is 3.5 rectangles or squares long. 3.5 squares long. And this says I'm going to have 2.5 rows. So here's my second row of 3.5. And here's my third row of 3.5. Notice that I end up with 1, 2, 3, 4, 5, 6 squares. But then I have a bunch of pieces of squares that are also inside the rectangle. Notice here's a half, there's a half outside. Here's a half inside, here's a half outside. Half inside, half outside, half inside, half outside, half inside, half outside. And notice what's left over here. You have an even smaller fraction of a square inside of here. This is a smaller square that measures 1/2 by 1/2, which is 1/4. 1/4 of a square inside, 3/4 of a square outside. So I end up with 1, 2, 3, 4, 5, 6. These two together make my 7th square. I guess I can get a pen and circle that. There's your 7th square. Here's your 8th square when you put those two halves together. And you're left with 3/4 of a square inside as well. There's your 8.75. I think that's pretty cool. Now, notice we don't count those things that are on the outside. They are not part of our solution. Here's another rectangle. I'd like you to pause the video and use your formula, substitute, simplify method, formula, substitute, simplify, to try and find the area of this rectangle. I'm going to go ahead and assume you've done that, and I'm going to go ahead and hop right on in. Our formula is length times width. We always rewrite that. I plug in the specific lengths and widths for this rectangle, and then I multiply those decimals together to get 29.16. What we're saying is that's the number of squares it would take to fill this if each square measured 1 centimeter by 1 centimeter. Notice the other examples, we're using inch squares. Centimeter squares are much smaller. Here's another rectangle. If you would, go ahead and pause the video, try your formula substitute simplify method to see if you can find the area of this rectangle. Again, I'm going to assume you've already done that. We start with our general formula. We plug in the specific values for this rectangle, and then off to the side on scrap paper somewhere we work out the multiplication, and we come up with 91.02. This is square feet. That means that if I'm filling this shape up, I'm filling it with squares that each measure 1 foot by 1 foot on each side. That's all we have for today. I do appreciate you taking the time to join us. Make sure when you're working out problems like this that you take the time to set up your formula substitute and simplify. What I find with my students is a lot of times they will begin to just grab this formula because they're familiar with it, and they'll start to use it with every single shape. Each shape is going to have its own area formula, and we need to make sure we know which shapes go with which formula. I know a lot of this was probably familiar to you. However, keep in mind that we're going to be expanding on this idea as we begin to talk about parallelograms and triangles where the squares don't necessarily fit as easily. So this review is really going to be useful for us going forward. Thank you so much for watching. Please take the time to give us a big old thumbs up. Make sure you ring that bell to turn on your notifications so you can hear all the new things coming from us here at Nunley Math. You guys take care of yourselves. Have a great day, all right? Bye-bye.